Hello friends, in this video we are going to discuss about the effect of light on P-type semiconductor. So let us consider a P-type semiconductor bar. So this is a P-type semiconductor bar. So in this P-type semiconductor bar, we know that this P-type semiconductor has large amount of holes with respect to the electron concentration. So let us assume that this P-type semiconductor is under thermal equilibrium condition. So under thermal equilibrium condition, let us consider that the electron concentration will be or is equals to the N P, and the hole concentration is equals to P P. And since this Pp, that is the hole concentration, is very much greater than the electron concentration, that's why the semiconductor is a P-type material. So all this thing is before the incident of light. Now let us consider that a light has been incident on this semiconductor. So this is the light that is incidenting on this semiconductor. So we can say this is the light, and we know that light means the photon particles, and the photon particle energy is h nu, where nu is the frequency of the light. So these photons, after incidenting on the semiconductor, will break some covalent bonds. So if it breaks some covalent bonds inside the semiconductor, then electron hole pair will be generated. So there will be an excess electron concentration del N, and excess hole concentration del P will be generated at this end of the semiconductor where the light is incidented. So we can say that del N is the excess electron concentration that is generated due to the incident of light. Similarly, del P is the excess hole concentration generated due to the incident of light. So that's why we can say that electron and holes are generated due to the light incident. Now these holes and electrons are generated in pairs. That means we know that electron and holes are generated in pairs. So since they have generated in pairs, so we can say that the excess electron concentration is equals to the excess hole concentration, because they have generated in pairs. Now let us assume that after the incident of light, the total electron concentration, that is after light incident, the total electron concentration is in P. If Nt is the total electron concentration, then we can say that Nt will now be the electron concentration before the light incident, that is Np, and after the light incident, del N amount of electron has been generated, so Np plus del N. Similarly, if Pt is the whole concentration after the light incident inside the P-type semiconductor, then it will be P suffix P, that is the whole concentration before the light incident plus the excess whole concentration. Now, under the low level injection, we know that the excess carrier concentration, that is del N or del P, should be very much less than the majority carrier concentration. We have here considered about the P-type material, and in the P-type material the majority carrier concentration is the whole concentration, that is Pp. So del N should be too much less than the Pp. Similarly, del P should be very much less than the whole concentration, that is the majority carrier concentration. Now, from this equation, we can see that this is the minority carrier concentration and this is the majority carrier concentration. So we can write that Pt, that is the majority carrier concentration, will be equals to P suffix P, because del P is very much less than the Pp, so we can neglect the del P part. But in the minority carrier concentration, that is the Nt, will be equals to Np plus del N. We cannot neglect this del N part with respect to Np, because Np and del N are comparable to each other. So we can see here that the percentage change in majority carrier concentration, that is the whole concentration, because we have considered the P-type semiconductor. So percentage change in the majority carrier concentration, that is the whole concentration, is negligible due to light incident. The percentage change in minority carrier, that is the electron concentration, is large due to light incident. That means when light incident on a P-type semiconductor, the electron concentration of the P-type semiconductor will be changed by a large amount, because electron concentration is the minority carrier concentration. So we can say that if Gn is the generation rate of excess electron, and if Gp is the generation rate of excess hole, then we can say that Gn will be equals to Gp because electron and hole are generated in pairs. Sometimes this generation rate is also called G optical. So this G optical means optical generation rate. In this way, we can describe that what will happen inside the semiconductor carrier concentration in a P-type semiconductor after the light incident. So this is all about the light incident phenomena taking place on a P-type semiconductor. Thank you.